Welcome to another 1 Minute Math video. Today's video will be how to perform partial fraction decomposition. Given x plus 7 divided by x squared minus x minus 6. We'll first factor the denominator, which becomes x minus 3 times x plus 2. Here we'll have two distinct linear factors. So this means that we're going to have two fractions. One fraction with the denominator of x minus 3. Another fraction with the denominator of x plus 2. We don't know the numerator, so let's call it a and b. Now, we just need to solve for a and b, and we have our partial fraction decomposition. To do this, let's multiply both sides by the original denominator, x squared minus x minus 6, or its factor form, x minus 3 times x plus 2. On the left side of equal signs, the x minus 3 and x plus 2 will cancel, leaving just x plus 7. On the right side of the equal sign, for the fraction with the a, we notice that x minus 3 will cancel, leaving a times x plus 2. For the fraction with the b, we'll notice that x plus 2 will cancel, leaving b times x minus 3. From here, we can let x equals any value you want. You can let x equals 0, x equals 1, x equals 2, x equals negative 1, x equals 1/2, x equals 2/3. Whatever x value you want. But if you choose particular x values, it will make the problem easier, such as, let's take a look at this a times x plus 2. What happened if you let x equals negative 2? We'll substitute that in, and we'll get this, which will simplify to 5 equals to 0 plus negative 5b. From here, we can divide both sides by 5, and we get b to be negative 1. So we solve for the b term if we just let x equals negative 2. How do we solve for the a term? Well, since we look at the a times x plus 2, let's now look at the b times x minus 3. What happens if you let x equals 3 this time? We'll substitute it in, and we'll get this. We'll simplify it, and we get 10 is equal to 5a plus 0. We can divide both sides by 5, and we get a equals 2. So notice that if we choose particular x value, you make the problem much easier to solve. Since we have a and b, now last step is to write the partial fraction decomposition. So we have x plus 7 over x squared minus x minus 6 is equal to a over x minus 3 plus b over x plus 2, where a is 2 and b is negative 1. And that is our partial fraction decomposition. Here's our second example, given 8 over x cubed minus 6x squared plus 8x. We'll factor the denominator, and that will become x times x minus 2 times x minus 4. In this example, we'll notice there's not two distinct linear factors, but there are three distinct linear factors, meaning we're going to have three different fractions. One fraction with the denominator of x, another fraction with the denominator of x minus 2, and a third fraction with the denominator of x minus 4. We don't know the numerator, so let's call it a, b, and c. Now let's get rid of the denominators by multiplying both sides by the original denominator, x cubed minus 6x squared plus 8x, or its factor form, x times x minus 2 times x minus 4. Now, looking at the left side of the equal sign, we notice that there's an x minus 2, and x minus 4 in both the numerator and denominator, so they'll cancel out, leaving just 8. And then for the right side of the equal sign, the fraction with the a term, we notice the x will cancel, leaving a times x minus 2 times x minus 4. Now, for the fraction with the b terms, the x minus 2 are in the numerator and denominator, so they will cancel, leaving b times x minus 4. And for the fraction with the c terms, we notice the x minus 4 are both in the numerator and denominator, so we're left with c times x minus 2. Just like the first example, we can choose any x value you want, but you choose particular x values to make the problem much easier. So let's look right here. What happened if you let x equals 2? If you let x equals 2 and substitute in, we'll get this. Simplify it, we get 8 is equal to 0 plus negative 4b plus 0. Notice here, we got rid of both the a and c terms, so we can just worry about the b term. Well, divide both sides by negative 4, and we get b to be negative 2. So we solve for b. What about the other two, b, like a and c? Well, instead of looking at x minus 2, let's look at the x minus 4. So what happened if you let x equals 4? We'll substitute that in, and we get this, which simplifies to 8 is equal to 0 plus 0 plus 8c. Notice when x equals 4, the a's and b disappear and left with c. Divide both sides by 8, and you get c equals 1. And lastly, well, we have x minus 4 already, so let's look at this x. What happens if you let x equal 0? Substitute that in. We get 8 is equal to 8a plus 0 plus 0. Simplify this, and we get a equals 1. So we've solved for a, b, and c. Lastly, we just need to write the partial fraction decomposition. So 8 over x cubed minus 6x squared plus 8x is equal to a over x plus b over x minus 2 plus c over x minus 4, where a is 1, b is negative 2, and c is 1. So that is our partial fraction decomposition for this second example. Here's a third example. 7x squared plus 21x minus 6 divided by 2x cubed plus 3x squared minus 2x. We'll factor the denominator, and that's going to be x times x plus 2 times 2x minus 1. Hence, we have three distinct linear factors. So we're going to have three fractions. First fraction is going to have a denominator of x. Second fraction will have a denominator of x plus 2. And third fraction will have the denominator of 2x minus 1. We don't know the numerator, so let's call it a, b, and c. Let's multiply both sides by the original denominator, 2x cubed plus 3x squared minus 2x, or the factor form, x times x plus 2 times 2x minus 1. On the fraction on the left side of the equal signs, there's an x plus 2, and 2x minus 1 in both the numerator and denominator, so they all cancel out, leaving 7x squared plus 21x minus 6. On the right side of the equal sign, on the fraction with the a, we know there's an x in the numerator and denominator, leaving a times x plus 2 times 2x minus 1. For the fraction with the b term, there's an x plus 2 in the numerator and denominator, so those will cancel, leaving b times x times 2x minus 1. And for the fraction with the c terms, there's a 2x minus 1 in both the numerator and denominator, leaving c times x plus 2. Now from here, we can choose any x values we want. We don't have to go in descending order as well. So let's look right here at the x term. Let's let x equal 0. Let's substitute x equals 0 in, and to make things a little faster, let's simplify as we go. So when x equals 0, the 7x squared plus 21x minus 6 becomes negative 6. And then we have a times x plus 2 times 2x minus 1, which is a times 2 times negative 1. And the one with the b terms, we get 0. And the one with the c term, we get 0. Don't assume they make zeros. Actually check to make sure they actually do make zeros. Simplify this, we get 3 equals to a. And so we found a. Now, instead of looking at x, let's look at this x plus 2. Let x equals negative 2. Alright, we'll substitute x equals negative 2 and simplify as we go. So, for the 7x squared plus 21x minus 6, 7 times negative 2 quantity squared is just 28. 21 times negative 2 is negative 42, and negative 6 times, well, just negative 6. And then on the right side equal sign, we have 0 plus b times negative 2 times negative 5 plus 0. Simplify this, we get negative 20 is equal to 10b. Divide both by 10, we get b to be negative 2. Now, we're probably looking at this 2x minus 1, and you're probably thinking, let's let x equals 1/2. Yes, this will work. However, you're going to be dealing with 7 times 1/2 quantity square plus 21 times 1/2 minus 6. So you're going to be dealing with halves. You're going to deal with non-integers. So let's just pick a different x values, just to test. Well, since we already used x equals 0, which is the easiest value to use, the next one will be x equals 1. So what happens if you let x equals 1? We'll substitute that in, and we get this. 7 plus 21 minus 6 is equal to a times 3 times 1, plus b times 1 times 1, plus c times 1 times 3. Simplify this, and we get 22 is equal to 3a plus b plus 3c. But you're probably wondering, wait, we didn't eliminate a and b to get c by itself. But wait, didn't we already solve for a and b? Let's use it. So if you use a equals 3 and b equals negative 2 by substituting it in, simplify it, simplify some more, we got c. C is 5. So what I'm saying here is, just because it doesn't eliminate a and b, doesn't mean you can't solve for c. Use the values that you solved for already. Alright, since we have a, b, and c, let's write our partial fraction decomposition. So 7x squared plus 21x minus 6 over 2x cubed plus 3x squared minus 2x is equal to a over x plus b over x plus 2 plus c over 2x minus 1, where a is 3, b is negative 2, and c is 5. So that's our partial fraction decomposition for this problem. In the previous three examples we solved, we noticed that we have a, b, and c to be all integers. But what happened when there's not an integer? Let's solve it with this last example. Given 3x squared minus 4x plus 3 over x minus 2 times x minus 1 times x plus 1. Here you notice the denominator is all factor for you, and they're all distinct linear factors, and there's 3 of them. So we're going to have 3 fractions. One fraction with denominator x minus 2, another with denominator of x minus 1, and the last fraction with denominator of x plus 1. We don't know the numerator, so again, let's call it a, b, and c. So let's make things a little more faster. Let's multiply both sides by the original denominator, x minus 2 times x minus 1 times x plus 1. So on the left side equal sign, we'll be left with 3x squared minus 4x plus 3. For the fraction with the a term on the right, we notice the x minus 2 is going to cancel, leaving a times x minus 1 times x plus 1. And then for the fraction with the b terms, the x minus 1 cancel, leaving b times x minus 2 times x plus 1. And for the fraction with the c term, the x plus 1 will cancel, leaving c times x minus 2 times x minus 1. Now let's look at this x minus 1. Let's let x equals 1. Substitute that in, and we'll get this. 3 minus 4 plus 3 is equal to 0, plus b times negative 1 times 2 plus 0. Do make sure that they actually do make 0. Don't assume it's 0. Okay? Alright, simplify, and we get 2 is equal to negative 2b, or b is negative 1. So we solve for b. Now, let's look at this x plus 1. What happened when we let x equals negative 1? We'll substitute it in, simplify, and we get 3 plus 4 plus 3 is equal to 0 plus c times negative 3 times negative 2. Simplify this, we get 10 equals 6c, or c is equal to 10 over 6, which can be simplified to 5 over 3. Lastly, instead of looking at the x plus 1, let's look at this x minus 2. If we let x equals 2, substitute this in, simplify, we get 12 minus a plus 3 is equal to a times 1 times 3 plus 0 plus 0. Simplify this, we get 7 equals 3a, or a equals 7/3. So we solve for a, b, and c. Now let's start our partial fraction decomposition. So this 3x squared minus 4x plus 3 over x minus 2 times x minus 1 times x plus 1 is going to be equal to a over x minus 2 plus b over x minus 1 plus c over x plus 1, where a is 7/3, b is negative 1, and c is 5/3. If you want, you could simplify this and it'll become something like this, but it's really up to you. So this is our partial fraction decomposition. Subscribe for more math content. Thank you.